So we're going to finish this chapter by finding volume by using the washer method. A washer is just a flat ring with a hole in the middle, and it could be represented by two concentric circles. Concentric meaning they share the same center. So you have the outer circle that has a radius of capital R, and you have the inner circle that has radius lowercase r, and then it has a thickness. So to find the volume, we would have to find the area of the outside circle, subtract the area from the inner circle, and multiply by the thickness. Let me show you what it will look like. So here we have two functions, f of x, g of x, and the region is enclosed by x equals a, x equals b. So this is the region, and we are going to revolve about the x-axis. But before I show you something else, notice that the region and the axis of rotation, there's a gap in between. That's why it's called washers. So when it revolves, you get a circle or a washer with a hole in the middle. And to find that volume, we're going to multiply pi with r squared, which r is, this one is the outer radius, so basically this distance, and g, the one we're taking away, is the inner radius, which is this distance here, and we square it. That will give us volume. So when you revolve it, you get this 3D solid, three-dimensional solid, and there's a hole in the middle, and that's why it's called washer method. So here we see the actual definition of volume of a solid of revolution using the washer method. But what I want you to look at is this. The integral is going to be pi, and the limits of integration are going to go from a to b, which is the vertical lines, and then it says f of x squared. But what I want you to think about is f of x, think of it as the function that is furthest away from the axis of rotation, and your g squared, your function g squared, is the function that is closest to the axis of rotation, and that'll make things way easier. Okay, let's dive into the first example. Find the volume of the solid of revolution generated by revolving the region bounded by the graphs of y equals 2 over x and y equals 3 minus x about the x-axis. So here I already drew the graphs, and first thing I want to do is I want to shade the region. So here's the region, and since I was careful when I drew this, I can see where they intersect. But if you don't see it, if you don't have graph paper, this is how you find the points of intersection. So points of intersection. To find those points of intersection, you set the equations equal to each other. So 2 over x equals 3 minus x. Now we want to solve for x. So we're going to multiply both sides by x, and we get 2 equals 3x minus x squared. I want to make sure that the x squared is positive, so I will move the negative x squared to the other side and this positive 3x to the other side, and it'll look like this. X squared minus 3x plus 2 equals 0. This is a quadratic, so now we're going to factor it. We need two numbers that multiply to a positive 2, but they add up to a negative 3. That would be x minus 2, x minus 1 equals to 0. We factored it, so now we solve by just taking the opposite, x equals 2 or x equals 1. Those are the points of intersection which I already have there. So now we're going to set up our integral to find the volume. So volume is pi, the integral. Now our limits of integration, since we are revolving about the, let me extend this, the x-axis, then my limits of integration are going to be the x values, which in this case is x equals 1, x equals 2. From 1 to 2. Now, we said earlier, I said that you want to see which function is furthest away from the axis of rotation. And you want to find that distance. To find the distance, you subtract. So it seems to me like this red line is furthest away from the axis of rotation, top minus bottom. So that means your function minus 0, because the axis of rotation is the x-axis, which is y equals 0. So again, the function that is furthest away from the axis of rotation, and it'll be the function minus 0. Remember that. So it's parentheses 3 minus x squared minus, now it's the function that is closest to the axis of rotation, which in this situation it's the blue curve. Notice the blue curve is closer to the axis of rotation, and that blue curve is 2 over x. So it'll be minus 2 over x squared dx. Let's expand. So pi, the integral from 1 to 2. To expand this one, remember what I taught you. So if I'm going to expand that, that's going to be 9 minus 6x plus x squared. And minus, when I square the second one, that one's easy. That's going to be 4 over x squared dx. So that is my function. So now we're going to take the antiderivative. So pi, the antiderivative of 9 is going to be 9x minus the antiderivative of 6x is going to be 6x squared over 2, and we'll reduce it right now, plus antiderivative x cubed over 3 minus, now let's see, think of a little side note, 4 over x squared as 4 times 1 over x squared. So what we're basically looking is for the antiderivative of negative 1 over x squared, which you should be familiar with. So my answer is going to be 4 over x, and it's going to be positive. And it's going to go from 1 to 2. Positive because the antiderivative of 1 over x is negative 1 over x squared, so it's positive. Before we evaluate them, I just want to simplify a little bit. So it'll be pi 9x minus 3x squared plus x cubed over 3 plus 4 over x, and we're going to evaluate from 1 to 2. Next step, let's plug them in. This one's going to be kind of long. Let's see. So I'm going to start over here. Pi. First we plug in the top one. So it'll be 9 times 2 minus 3 times 2 squared plus 2 cubed over 3 plus 4 over 2. Minus, now we have to plug in the 1. Now let's think about it. If I plug in the 1 here, that gives me 9. This gives me 3. This gives me 1 over 3. And this gives me 4. Make things easy. So it'll be 9 minus 3 plus 1 over 3 plus 4. And start simplifying. Pi 9 times 2 is 18 minus, here we have to follow order operation, so that means square it first, so that gives me 4 times 3, negative 12, plus 8 over 3 plus 2 minus, better yet, let's distribute. So minus 9 plus 3 minus 1/3 minus 4. Okay, now let's simplify. So if I combine like terms, 18 minus 12 plus 2 minus 9 plus 3 minus 4, that is going to give me negative 2. Now, if we combine 8/3 and a negative 1/3, that will be a positive 7/3. Now what I want to do is rewrite the 2 as negative 6 over 3, because that gives me negative 2, plus 7 over 3. And if I subtract that, or I combine negative 6 over 3 plus 7 over 3, that gives me 1 over 3 times pi is just pi over 3 cubic units. Okay, this next example, I already graphed it, and the reason is because look at the points of intersection. Those are not easy to find by hand, so you have to do it with a calculator. I did it with Desmos, but that's what it looks like. So what I'll do right now is shade the region. So let me shade the region. Here's the region. Next thing I want to look at, the points of intersection, which is from here to here, the x values, because we are going to revolve about the x-axis. Now, this is my axis of rotation. Right here, the x-axis, which is y equals 0. Here, let me write that down. So y equals 0. So the function that is furthest away from the axis of rotation is the parabola that's upside down. Notice that that one is further away. There's a gap in here. So that means washers. So again, the function furthest away is the parabola. So in reality, just think of it as the parabola minus this y value, which is 0. So now, let's start setting it up. So volume equals pi integral from negative 2.713 all the way to 0.29. And the top function, this one, or the function that is furthest away from the axis of rotation, is the parabola. So that's going to go first. So it'll be negative x squared minus 2x plus 2 squared minus, and then the function that is closest to the axis of rotation is this one, which is e to the x. So it's e to the x minus 0, which is just e to the x. So it'll be e to the x squared dx. Okay, but before we plug it into the calculator, I want to make sure that I rewrite this. So if I rewrite it, yes, I'm going to do it again. From negative 2.713 to 0.29. This one stays the same. I don't really need parentheses around. Oh yeah, I do. Negative x squared minus 2x plus 2 squared minus e to the x squared is just e to the 2x. And we get 48.550 cubic units. Don't forget that when you get your answer, multiply by pi at the end. Okay, next example, which I already graphed. And it says find the volume of the solid revolution generated by revolving the region bounded by the graphs of y equals 2x and y equals x squared about the line y equals -5. Now, this time, it's not about the x-axis. It's about y equals 5. So I'm gonna make my little note that I'm rotating about that. But notice, it is a horizontal axis, just like the x-axis. It's horizontal. So we need to find the points of intersection. These are pretty simple. It's going to be at 0 and 2. But let me just show you how to get it anyway. So we're going to set the equations equal to each other. So we're going to say x squared equals 2x. In this situation, I do not want you to divide by x. What I need you to do is set it equal to 0. So that means move the 2x. So it'll be x squared minus 2x equals to 0. It's a quadratic, so I'm going to factor the common factor. Common factor is x, so x. And inside we're left with x minus 2 equals to 0. So now we have two answers, either x equals 0 or x equal 2. Those are my points of intersection, just like I said. So at 0 and 2. Now, I'm going to shape the region that we are going to revolve. Well, too big. Hang on. Here we go. So this is the region. Now, the axis of rotation is way down there. So from the looks of things, if this is the axis of rotation, it looks to me like the red function is the one furthest away. Notice it is the one furthest away. And the blue parabola is the one closest. So if we were rotating about the x-axis, then it would just be the function 2x squared. But now we're no longer here on the x-axis. We are way down here. So you have to add that distance. So we can say that it is the line, which is 2x minus a -5. Again, the line minus a -5. So that makes it the line plus 5, because we're adding that distance, plus 5. So let me start setting it up. So it'll be volume equals pi integral from 0 to 2, just like we said earlier. And it's going to be 2x plus 5 squared. Again, think of it as 2x minus a -5, which gives me 2x plus 5. We're going to do the same thing for the second function. It's our parabola, which is x squared minus a -5. Again, x squared minus a -5. That would be x squared plus 5. So here it'll be minus, parentheses, x squared plus 5, all of it squared, and then dx. This one we're able to expand, so let's expand. Pi integral from 0 to 2. If I expand this first binomial, that's going to give me 4x squared plus 20x plus 25 minus, and I'm going to put parentheses around it because I'm going to have more than one term. It'll give me x to the 4th plus 10x squared plus 25 with respect to x. Now we'll combine like terms, and then we can integrate. So pi 0 to 2 equals. My integrand is going to look like this. I only have one x to the fourth term, and if I distribute the negative, I get negative x to the fourth. Now my x squareds, I have 4x squared, and if I distribute this negative to the 10x squared, and I combine them, that gives me negative 6x squared. Now my x's, there's only one term, so I'm just going to bring it along, plus 20x. And then I notice that this positive 25, and then I distribute this negative to this 25, they cancel out. So that's it, dx. And for this one, I would like you to use a calculator, so let's plug it into the calculator. Let's see what we. Okay, on to the next. Now we want to find the volume by revolving the region bounded by the graphs of 1 over x, which I already have, y equals 0, x equals 1, x equals 4, and we will revolve about the line y equals 4. So this one's here. Let me rewrite that here. There. There's a lot of stuff happening here. So let's find out what is the region. Now notice it said bounded by 1 over x, which is this one, 1 over x. The lines x equals 1, x equals 4, and y equals 0. Y equals 0 is the x-axis, so it's this region right here. That is the region. Even though it doesn't say that it's a function, think of y equals 0 as a function. You're going to need it for this one because of this. Now, the axis of rotation is way over here. And the function that is furthest away is the x-axis, y equals 0. So to find the distance between 2 points, you always subtract. So in reality, think of you're getting 4, the function 4, minus 0, which is just 4. So the function y, which is 4, minus 0 is just 4. Also, this function here, 1 over x, is closer to the axis of rotation, so it'll be top minus bottom to find distance. 4 minus 1 over x. Again, 4 minus 1 over x. And we already have the limits of integration. It's these vertical lines. X equals 1, x equals 4. This one got erased. Here we go. So let's set up our integral. And for this one, we're going to use the calculator also. So volume equals pi integral from 1 to 4. So again, it's 4 minus 0. 4 minus 0. That's the function that is furthest away from the axis of rotation. So it'll look like this. 4 minus 0 squared minus, and then again, this function 1 over x is closest to the axis of rotation, so it'll be top minus bottom, 4 minus 1 over x. 4 minus 1 over x, and we have to square that, dx. Now let me just simplify things a little bit. Since this is a calculator problem, it'll be pi integral from 1 to 4. Now 4 minus 0 is 4, and 4 squared is 16. So 16 minus, we're going to keep this one in the parentheses. We're going to square it. Everything with respect to x. So this is what I want you to plug into the calculator. So let's plug it in. And the calculator gives us 32.485 cubic units. Remember, it's always going to be 3 decimal places. Okay, Our last example of revolving about a horizontal axis. So we want to find the volume by revolving the region bounded by the graphs of y equals square root of x, y equals 0, and the x value has to be from 0 to 4 about y equals negative 4. Now let's see, what does that mean? So we should know the basic graph of square root of x, which is this one, y equals square root of x, and then we have a restriction from 0 to 4, from 0 to 4. So from 0 all the way to 4, that's where we stop. So let me shade the region. Here's the region. Remember that the x-axis, that's going to be our y equals 0. So now we look for the function that is furthest away from the axis of rotation. The function that is furthest away from the axis of rotation. That would be the blue one, which is square root of x. That's the furthest one. Now you might be thinking, okay, what's the second one? The second one is this, y equals 0, because you need to have that boundary. It's bounded. The region is bounded by the graph y equals square root of x and y equals 0. So our second function is going to be 0 minus a negative 4. Again, 0 minus a negative 4. Well, 0 minus a negative 4 is just a positive 4. Okay? So let's set it up. Let's set up our integral. So volume is pi, the integral from 0 to 4, and the function that is furthest away is going to be this one minus a negative 4. So that will give me the square root of x. Minus a negative 4 means plus 4 squared. Minus, and now the function that is closest will be y equals 0. So that means 0 minus a negative 4. Again, I'm going to say it again. So that will give me a positive 4. So it's going to be 4 squared with respect to x. Now, let's simplify. So pi, 0 to 4. I'm going to expand this. So remember how to expand that binomial. Shortcut. So if I expand it, I get x plus 8 square root of x plus 16 minus 16. Now, be careful here because I don't want you thinking that this is going to be a positive 16. It's not. First you square it. Follow order of operations. Please excuse my dear Aunt Sally. So first you square it. 4 squared, that's 16. There's a negative outside, so that makes it negative 16. So let's see. Let's simplify to make things easy or easier. Pi, integral from 0 to 4. So x plus, I'm going to rewrite the square root of x as x to the 1/2 power. So 8 times x to the 1/2 power. And the 16 minus 16 is gone. So that's it. I'm left with this. Let's integrate. Pi, the antiderivative of x is x squared over 2 plus. Now for the next one, I'm just going to take the antiderivative of that and then multiply the result by 8. So it'll be 8 times. I'm going to add 1 to the exponent. So 1/2 plus 1, or better yet, 1/2 plus 2/2, that would be x to the 3/2 power. And then I have to multiply by the reciprocal. So I need to move this a little bit to the side. Hold on. Let's see. There we go. So the reciprocal of 3/2 is 2/3. And that's going to be evaluated from 0 to 4. Now before I evaluate, I just want to simplify this one here, this part here. So it'll be pi x squared over 2 plus 16 over 3 x to the 3/2 power from 0 to 4. Now before I actually evaluate, I notice that if I plug in a 0 here, it's going to give me 0. If I plug in the 0 here, it's going to give me 0. So I'm just going to ignore it and just plug in the 4 and not worry about the 0 for this situation. So then it'll be this, pi, plug in the 4, that's going to be 4 squared over 2 plus 16 over 3 times 4 raised to the 3/2 power. Let's simplify. Pi. So this gives me 4 squared is 16 divided by 2 is 8 plus, and for this one, this part right here tells me that first I need to take the square root of 4, and then the result I need to cube it. Again, it's square root of 4 and then cube it, and then the result we multiply it with 16 over 3. So here we go. The square root of 4 is 2. 2 cubed is 8. 8 times 16 is 128, and that is over 3. Now let's see, can we divide that? No, we can't. So what that means is that I need to rewrite the 8 as a fraction with a denominator of 3. So that would be 24 over 3, because that gives me 8 plus 128 over 3. Now I can combine those two. 128 plus 24, that's going to give me 152. So final answer is 152 pi over 3 cubic units. Okay, so now let's go on to the next example. This time we're going to find the volume by revolving about the y-axis. So what that means is that I need to solve these two functions in terms of y. So I need to solve for x. So let's see, before that, it's already graphed. So you noticed I'm going to shade in the region. Here is my region. And we need to find the points of intersection. Now, I know that we can see them there, the points of intersection, but just to practice, we're going to find it by setting the equations equal to each other. So let's do that. Let's see, what is it? X squared. So x squared equals negative the quantity x minus 2 squared plus 4. So what I want to do is expand the binomial. So x squared equals, keep that negative there. If I expand the binomial, it gives me x squared minus 4x plus 4, and then plus 4. Now I can distribute the negative. Make sure you keep those parentheses. X squared equals negative x squared plus 4x minus 4 plus 4. So then I notice that the negative 4 and the positive 4 will cancel out, and I want to set it equal to 0. So when I move the negative x squared to that side and the positive 4x to the other side, we get 2x squared minus 4x equals to 0. Now here we're going to solve. So let's factor out the common factor, which is 2x. That leaves me with x minus 2 equals 0. So solving for x will give me x equals 2 So it's just the opposite. And for this one, it's just x equals 0. So the points of intersection are x equals 0, x equals. So now we're going to go back. And it was at 0 and 2. Those are going to be, well, not my limits of integration, because since I need to revolve about the y-axis, I need to find the y value, this y value. That's easy. All you have to do is plug it into the function. And when x is 2, y is 4. So there. So now we have that. Now we need to solve for x. So let me start with this one. I'm going to rewrite it as y equals x squared. So I take the square root of both sides. I get positive, negative, square root of y equals to x. So we have 2, the positive, and the negative square root of y. But which one do we choose? So the right branch of the parabola is y equals square root of y. And the left, this one is, it's x. And this one is x equals negative square root of y. So notice that we're going to use the positive one. So now, if I solve this equation here, run out of room. If I solve this one for x, we'll rewrite it as y equals negative plus 4. So now what I'll do is I'm going to get rid of the 4, send it to that side. So again, the positive 4 becomes a negative 4 there. Then I get rid of the negative. Then I get rid of the square. And then we leave the x by itself. So let's do that. So it'll be y minus 4 equals to negative x minus 2 squared. So imagine dividing by a negative. So I can get rid of this negative in front of the parentheses. So that'll give me 4 minus y equals to x minus 2 squared. If I take the square root of both sides, we end up with square root 4 minus y, positive negative, equals x minus 2. Add 2 to the other side. Now the 2, I'm going to place it in front of the plus or minus. So 2 plus or minus square root 4 minus y equals to x. Okay, well, which one do we choose? We're going to choose the negative one. Let me explain. So this one, the orange one, has 2 branches. This side will be the positive side, and this side will be the negative side. So we're choosing that, the negative one, because of this. If you look at your axis of rotation, which is the y-axis, the function that is furthest away from the axis of rotation is the purple one. So think of it as finding the distance, and we always find it by going right minus left, right minus left. And the function that is closest to the axis of rotation is this part of the parabola, the orange one. That would be the negative one. So it'll be this function minus 0. This one minus 0. Let's set up the integral. And this will be a calculator problem. So volume equals pi, the integral from 0 to 4. Remember, this time it's from this y value to this y value. So from 0 to 4. Then the function that is furthest away from the axis of rotation, that would be this one, the purple one. And this side of the branch is the positive root. So it'll be that function minus 0, which is just square root of y squared minus the function that is closest to the axis of rotation, which would be this one. And we said that this would be the negative part of the branch. If you don't see it, all you have to do is plug in an x value or a y value into your function. No, the x would work better into the function to see which side you get. So now this one is going to be, what was the function? Oh yeah, 2 minus square root 4 minus y parentheses squared dy. So now if we simplify this a little bit, we can plug it into the calculator. Actually, we can just plug it in like this. Now, in your calculator, you're going to see that you don't have it in terms of y. So all you have to do is plug it in and use x. Use x with respect to x. It'll give you the same answer. If you plug it in to the calculator, your answer should be 16.755 cubic units. Remember, don't forget to multiply pi at the end. Okay, next example. Find the volume of the solid of revolution generated by revolving the region bounded by the graphs of y equals x to the 2/3 power, the x-axis, x equals 8 about the y-axis. Okay, so let's show the axis of rotation about the y-axis there. That tells me I need to change this equation, solve for x. This one already has x equals 8. It's already x equals something, so that's good. Let's find the region. So the region is bounded by the graphs of x equals 2 to the 3rd power. To the power of 2 over 3, sorry. So that would be this. The x-axis, that would be this. And x equals 8, that will be this. So this is the region that we want to revolve. Now, we want to revolve about the y-axis. So that tells me that I need to do right minus left. Now in this situation, the function that is furthest away from the axis of rotation will be this vertical line, x equals 8. So it's just 8 minus 0. 8 minus 0. And the function that is closest to the axis of rotation is the green one, which will be x raised to the 2/3 power minus 0. Again, this one minus 0, because the y-axis is x equals 0. So the first thing I need to do is rewrite the function in terms of x. So we have y equals x raised to 2/3 power, and to get rid of that exponent I'm going to raise both sides to the 3/2 power. So that's all you have to do. The exponent has to be the reciprocal. When you do that, you get y raised to 3/2 power equals to x. There you go, we solved for x. We need one more thing. We need to find the limits of integration, which for now it looks like from 0 to this y value here. Now to find the y value, even though you can see it there, all you have to do is plug in the x value into your function. So y equals 8 raised to 2/3 power. So 8 raised to 2/3 power, I like to do this first. This means take the cube root of 8, and then the result you square it. So again, take the cube root of 8 and then square the result. The cube root of 8 is 2, and if I raise it to the second power, I get 4. So my limits of integration are from 0 to 4 once again. So let's set it up. Volume equals pi integral from 0 to 4, we said. Now, this is where it gets a little tricky. People get confused. So the function that is furthest away from the axis of rotation is this vertical line. So it's just going to be 8 minus 0, and then we square it. So let me just write it like this. So it'll be just 8 minus 0 squared minus, now the function that is closest to the axis of rotation is the green one. So it'll be that function minus 0, which is just the function. And the function is y raised to the 3/2 power. So y raised to the 3/2 power squared dy. So now let's simplify before we integrate by hand this time. Pi integral 0 to 4. 8 minus 0 is 8, squared is 64, minus this 3/2 times 2 gives me 3, so it's just y cubed respect to y. Okay, so now this looks easy enough to integrate, so let's integrate it. So it'll be pi. The antiderivative of 64 with respect to y is 64y minus antiderivative of y cubed, y to the 4th over 4. Now be integrating from 0 to 4. Here, let me change it to bracket so we can have continuity. Okay, when one of my limits of integration is 0, I always check to make sure that if I plug it in, will I get 0? So if I plug it in here, yes. Plug it in here, yes. So I don't have to worry about it. All I have to do is plug in the 4. So pi integral 64 times 4 minus 4 to the 4th over 4, lots of 4's, equals, so now we use a calculator and we multiply 64 times 4, that is 256, so pi 256 minus, and then for this one we're gonna have, if I do 4 to the 4th divided by 4, that will be 64. And last thing is just to subtract those two. So 256 minus 64 will give me 192, times pi is just 192 pi cubic units. That is the volume. Okay, last example. We want to find the volume by revolving the region bounded by the graphs of y equals x cubed, x equals 0, y equals 1, about x equals -1. Seems like a lot, but it's not. Okay, so here we go. First of all, let's identify the axis of rotation. I already graphed it like I usually do, and we are revolving about x equals -1. There it is. Now the region is bounded by the graph, which is the pink one, x equals 0, which is the y-axis, and y equals 1, which is this horizontal line. So basically it's this region right here. And since we are revolving about a vertical axis, it's just like the y-axis, so that means I have to solve for x. Now, let's look at something else. Which function is furthest away from the axis of rotation? That would be the pink one. That's the one that's furthest away. So it's the function minus -1, because the distance from here to here is 1, but we use the x value, -1. So it's the function minus -1, which makes it the function plus 1. We're adding distance to it. It's getting further away. But we have to solve for x. And then the second function, the one that is closest to the axis of rotation, is, believe it or not, this y-axis, which is just x equals 0. So let me write it down here. X equals 0. Remember, it's bounded by x equals 0, y equals 1, and your function. Now, let's solve for x. So if I have y equals x cubed, then to solve for x, I just have to do the cube root, or take the cube root of both sides. So it's the cube root of y equals to x. That's the function we're going to use. And we need to find also the limits of integration. That's easy enough because of my graph. The lower limit is going to be from 0, and the upper limit is going to be 1. So we're going to go from 0 to 1. It's already there in your graph. So let's graph that. I'm sorry, set up the integral. So volume is pi integral from 0 to 1, we said. Now, again, let's do this again. The function that is furthest away from the axis of rotation is this pink one. So it's your function minus a -1. The function minus a -1. So the function is cube root of y minus a -1 squared. I'm going to write it out just like that so you guys can see it. Minus. Now, the function that is closest to the axis of rotation is x equals 0. So it's 0 minus a -1. Always go right to left. 0 minus a -1. So let me write it out like that. 0 minus a -1 squared dy with respect to y. So let's clean it up a little bit. So this will be pi integral from 0 to 1. This one, I'm going to just leave it like that. So it's a cube root of y plus 1 squared minus, this just gives me 1 squared is 1 dy. This one we can do by hand. So what I'll do is expand this binomial. So pi integral from 0 to 1. So this one, before I actually expand, let's think of cube root of y is the same as y to the 1/3 power. Okay, so y to the 1/3 power, if I raise it to the second power, it's going to give me y raised to the 2/3 power plus, I'm expanding this binomial, so it'll be 2 times the cube root of y, which I'm going to rewrite as 1/3, make things easier, plus 1, and then the minus 1 dy. So this part right here, I expanded the binomial, by using the shortcut that I've taught to you guys. So one more thing, let's simplify even more. So this will be y raised to the 2/3 power plus 2y raised to the 1/3 power, and the 1's cancel out, so I'm left with dy. That's why I want to simplify. Now we can anti-differentiate. So pi antiderivative of y to the 2/3 power, we have to add 1 to the exponent. That 1 is in the form of 3/3. So 2/3 plus 3/3 will give me 5/3. But remember, we multiply by the reciprocal of the exponent. So 3/5 plus. So when I take the antiderivative of this one, ignore the 2 for now. So it'll be 2 times. If I add 1 to the exponent, 1/3, that's going to give me 4/3. So y raised to the 4/3 power, but I have to multiply by the reciprocal, which is 3/4. And we will evaluate from 0 to 1. Before I actually evaluate, I want to make sure that it's simplified. And since I have a 0, if I plug it in here, it gives me 0. If I plug it in here, it gives me 0, so I will ignore it again. Always check though. So this will be, let's see, pi. So when I plug in a 1 to the y, that's just 1, so that gives me just 3/5 plus. When I plug in the 1 to this y, it also gives me 1. So that will be, let's see, 6/4, which reduces to 3/2. So now we need common denominator. So pi, common denominator will be 10. So the first fraction becomes 6/10, and the second fraction becomes 15/10, which gives me, when I add that up, gives me 21 pi over 10, and you can't reduce that anymore. And that is the final answer.